Yes, Shiran. This is 10th assignment of alkyl and aryl halides, and this is the last assignment of this chapter. Nomenclature. First IUPAC is very simple compound. I'm directly telling you this is 2,2-dichlorobutane. Second, CH3C. This is attached to two similar groups. Do you remember this type of group was present in DDT also, right? Same type of group. CHBr, CH3. This will be the direction of counting. Longest chain is of 4 carbon atoms, that is butane, right? So this will be 3 bromo 2 bis 4 dash chlorophenyl. If you remember, we named this group in the same manner in DDT. This is 4 dash chlorophenyl group. So 3 bromo 2 bis 4 dash chlorophenyl butane. Last compound. This is para C6H5Cl, then CH2, CH, CH3 twice. Wait a minute. CH2, CH, CH3 twice. Yes. This is the direction of counting. 1. This is 4 dash chlorophenyl. 2 methyl propane. 1 within brackets 4 dash, wait a minute. 1 4 dash chlorophenyl 2 methyl propane, and this is the one which we can classify. This is this is aryl halide. Now fill in the blanks. First sequence. Toluene with A gives benzyl chloride. So this is chlorine in the presence of sunlight. HNO means any radiation. Benzyl chloride reacted with B to give benzyl isocyanide. So this is AgCN. This is also obtained by the reverse reaction of C. According to reaction conditions, C is benzyl amine. C is benzyl amine. Second sequence. If we start from the backward reverse direction, ultimately products are iodoform and sodium propanoate, and B is a ketone. It means B contains this group for the preparation of iodoform, and it has 2 more carbon atoms because this part will change into sodium propanoate. And the other product is given, this changes into iodoform. This ketone is obtained by the reaction of A with aqueous NaOH. It means this A is a general dihalide. 2 halogen atoms on the same carbon atom. Third sequence. Secondary butyl alcohol with chlorine NaOH. Secondary butyl alcohol has the required group for the preparation of chloroform, bromoform, and iodoform. So in this compound, B is chloroform. B is chloroform, and C is sodium propanoate. A is sodium propanoate. Now B is reacted with ethylamine alcoholic OH heat. This is carbonylamine test. This will lead to the formation of ethyl isocyanide, false smelling product. Explain why. All questions of explain why, you'll find answers in your notes. Coming to fourth question, what happens when? I'll verbally explain. These are very simple questions. First question, ethylamine is warm with chloroform and alcoholic OH, alcoholic acid potash. This is the reaction. this will lead to the formation of a false smelling isocyanide. Second, benzene diazonium chloride is heated with HBr in the presence of copper metal. This is Gattermann's reaction. So Gattermann's reaction takes place to give bromobenzene. Distinguish between normal propyl chloride and isopropyl chloride. See. Isopropyl chloride is nothing but 2-chloropropane. It's 2-chloropropane, isopropyl chloride. React both the compounds with aqueous NaOH. In both the cases, we'll get alcohol, 1-propanol and 2-propanol. Now, 2-propanol has the required group for iodoform test. Now we'll perform iodoform test. Iodine NaOH. This is the one which has required group. This will give yellow crystalline solid iodoform and sodium acetate and other products. You'll write the balance equation. Ethylene chloride and ethylidene chloride. Ethylene chloride is vicinal dihalide. Ethylidene chloride is geminal dihalide. React with aqueous NaOH. When both are reacted with aqueous NaOH, in first case, we'll get an aldehyde. This will be, sorry, in first case, we'll get vicinal diol, ethane diol. In the second case, there will be 2 OH on the same carbon, which will lose water and ultimately give ethanol. Ethanol. Now, ethanol has required group for iodoform test. So when reacted with iodine NaOH, this will not give yellow crystalline solid, whereas this will give yellow crystalline solid, right? So react with iodine NaOH. No yellow crystalline solid. In this case, we'll get yellow crystalline solid, that is iodoform. You have to write balance equation. Conversions. Ethanol into 2-pentyne in 2 steps. Convert alcohol into alkyl halide by any method you remember. Then react with sodium propionate. Product is 2-pentyne. Isopropyl alcohol into normal hexane. Isopropyl alcohol into normal hexane. If we have 1 halopropane, Wood's reaction will give hexane. Now, convert this into alkyl halide. You know different methods. Convert alkyl halide into alkene, dehydrohalogenation. Convert propene into 1 halopropane. This is anti-Markovnikov addition. So HBr in the presence of organic peroxide will give 1 bromopropane followed by Wood's reaction. Ethylene chloride into ethylidene chloride. Ethylene chloride is vicinal. Ethylidene chloride is geminal. React with alcoholic KOH. With alcoholic KOH, we'll get an alkyne. Then react with HCl excess. According to Markovnikov's rule, you'll get 1,1-dihaloethane. Toluene into 2-phenyl ethane nitrile in 2 steps. Toluene into 2-phenyl ethane nitrile is this compound in 2 steps. First reaction is side chain halogenation, chlorine in the presence of sunlight. React with KCN. NSR, you'll get the final product. Propyne into 2-butyne. React with sodamide. This reaction I told you in one of the assignments earlier as well. This is class 11 reaction, acidic nature of alkynes. React with sodamide, you'll get sodium salt of propyne. Then react with halomethane. Halomethane. Toluene into benzyl alcohol in 2 steps. Toluene into benzyl alcohol in 2 steps. I hope you know both the steps. First is side chain chlorination in the presence of sunlight, and second step is aqueous NaOH, NSR. Next question. On reaction with aqueous NaOH, dextrorotated 2-bromobutane gives a levo-rotated 2-butanol by SN2 mechanism, while the product is a racemic mixture of 2-butanol by SN1 mechanism. Explain. This is a very lengthy answer. It's nothing but SN1, SN2 mechanisms have to be explained, which are there in your notes. But try to explain in short. Don't write too lengthy answer. Next. Which compound in each of the following pairs will react faster in SN1 mechanism? See, in SN1 mechanism, reactivity order is based on stability of intermediate carbonium ion. So on that basis, tertiary is more reactive than secondary, secondary more reactive than than primary. Now, first pair. In the first pair, first compound, that is 2-chloro-2-methyl propane, is more reactive because it is a tertiary alkyl halide, whereas the second compound of the pair is a secondary alkyl halide. Second pair, 1-chloropentane, 2-chloropentane. Obviously, 2-chloropentane will react faster, which is a secondary alkyl halide. Next question. Next question will take time, and in case this type of question is asked, this will have minimum weightage of 3 marks. It's a very interesting, very important question. Try to understand. A hydrocarbon A is a hydrocarbon, reacts with excess of HBr. HBr excess gives B, which on subsequent reaction with aqueous NaOH gives C. Reaction of C with iodine NaOH gives a yellow crystalline solid D. Iodine NaOH gives D. D is very clear. D is iodoform. And sodium salt of a branch chain carboxylic acid RCONA. Second product is E. Its formula is RCONA, and this is a branch chain. This is a branch chain compound. This is a branch chain compound, right? And it's also given that the molecular weight of this compound is 110. We have to identify all the compounds. One we already identified because this was very simple. First of all, we'll find out what is R, whether this is methyl, ethyl, propyl, what is the alkyl chain, that we'll find out. So this is R, C, O, O, Na is equal to 110, right? R we have to calculate what is the contribution of R in the molecular weight plus carbon 12, O, O, Na 110. This R will come out to 43. And 43 is the contribution of propyl chain. It means R is C3H7. Now, this R is C3H7. So this compound is C3H7CONA. But remember, this is a branch chain compound. It means compound E should be compound E should be sodium salt of isobutyric acid, because this is the branching. Now, in this compound C, which gives iodoform test, there should be CH3CHOH or CH3CO group. I'll repeat, since C gives iodoform test, it means compound C contains one of these two groups. Which one? That will decide later. Apart from that, this side, this alkyl chain is present, attached. So C is one of these two, right? Now, if C is this, then B should be alkyl halide with the same set of carbon atoms. If C is a ketone, then this compound should be a geminal dihalide with the same arrangement of carbon atoms, because geminal dihalide with aqueous NaOH will give a ketone and monohalide will give alcohol. Now, B is obtained by the reaction of A with excess of HBr. A may be alkane, alkene, or alkyne, but it reacts with HBr, and that too in excess. It means A should have more number of pi bonds. It means this is an alkyne, and this alkyne has same arrangement of carbon atoms. This is A. A is 3-methyl but-1-ine, 3-methyl-1-butyne. Now think, when this reacts with the excess of HBr, product is not this, product is this. And if B is this, then C is not this, C is this compound. So on this basis, we decide what are A, B, C, D, and E. So here, the word excess of HBr will be very important. Second, this product is branch chain product. That branching word is very important in deciding various reactants and products. Coming to next question. An organic compound A, when treated with alcoholic KOH, gave compound B. With HBr, B gave C, which is isomer of A. Wood's reaction of C gave 2,3-dimethyl-butane. This is a very simple question. And it is given that A and C are isomers of each other. A is 1-bromobutane, B is A is 1-bromopropane, B is propene, C is 2-bromopropane, because Wood's reaction of 2-bromopropane will give 2,3-dimethyl-butane. Now, in the last question, there are some compounds given, and we have to identify which of them will give positive iodoform test. I'm telling you only the answer, which of these will give positive iodoform test. In case you still have any doubt, you can ask now or you can ask later on a phone call. Out of these, third compound C, that is secondary butyl alcohol, will give positive iodoform test. Next, F, that is propanone, will give. Then 1-phenyl ethanol will give positive iodoform test. Next, ethanol will give, and 2-butanone will give positive iodoform test. So in case there is any doubt, first you have to do is you draw structures of these compounds and find out whether one of these two groups is present or not. But in case you still are not able to make out, you can ask me, I'll draw the structure and WhatsApp you, right?